巴士服務咧就係香港重要嘅公共交通服務之一。原來5G 嘅技術咧都可以協助疏導候車乘客㗎。Bus service is one of the most important public transportation services in Hong Kong. Do you know that 5G technology can help shorten bus queues? Our next guest speaker from KMB is going to share with us more in details. Now let me invite Mr. Martin Cateman, Deputy Operations Director, Planning and Support of KMB, to share with us the implementation of Smart People Counting Solution and Bus Interchange. 我哋跟住咧喺台上邊嘅就係九巴副車務總監、策劃及支援簡迪文先生，佢會為我哋分享 Smart People Counting Solution on Bus Interchange. Let's welcome Mr. Cateman.
I first want to thank you for inviting us here today and giving us this opportunity to share our Smart People Counting Solution bus interchanges with you. I want to manage your expectation first and let you know that we don't actually have a solution for counting smart people. The solution we have, hopefully, is a smart solution for counting ordinary people. A move away from the manual process that we've been using for quite a long time. So over the next 10 minutes, I'll tell you a little bit about us, about KMB, what we do, just so that you can put this solution into context. I'll give you an overview of the project that we have here, talk about some of the unique features that we've incorporated within this project, and then finally I'll just wrap up by letting you know about some of the benefits that the project is giving to us and in turn is giving to our passengers. So for KMB, the company was established in 1933 and we will celebrate our 90th anniversary next year. KMB is the largest franchise bus operator in Hong Kong and it's one of the largest in the world. We operate over 4,000 buses. The majority of them are double-decker buses, so you can imagine how many passengers we carry every day. We operate over 400 routes covering the new territories, Kowloon and also Hong Kong Island. We have routes that start from less than 10 kilometers and go to over 50 kilometers. Some are local circular routes and others are long-distance premium routes. Our average daily travel for each bus is about 240 kilometers. We operate services around the clock, although mostly we operate from 5 in the morning until about midnight. From this, I hope you can see that what we operate is quite a substantial service to the public, and manual monitoring of our services and planning based on our manual information gathering is quite resource intensive. And I think, as a few of the other speakers have also mentioned, it's getting harder and harder to employ people. So we have to look more and more about how we can use technology to assist us in our work. So the project we have here, people counting at bus interchanges, we've deployed this at 2 locations initially, one on the Tuen Mun Road bus interchange and one at the Tai Lam Tunnel interchange. The one you can see here is the setup at the Tuen Mun Road bus interchange. Bus interchanges involve a very dynamic passenger flow. For this one on the Tuen Mun Road, we have over 40 routes that go by this bus interchange. And this is a place where, in the case of the Tuen Mun Road bus interchange, about 40,000 passengers every day can change from one bus to another bus. This is quite an isolated location. I don't know if you've been there before, but it's not like Nathan Road. If you're on Nathan Road and your bus doesn't come, you can walk to the MTR, you can catch a taxi, you could walk home. If you're at the Tuen Mun Road bus interchange, you can't walk anywhere. And there's no MTR and there's no taxi. You're basically stuck there until a bus comes. So it's very important for us that we can manage if our services are disrupted or if our services are insufficient. The counting of queuing passengers allows us to do 2 things. It aids us in terms of planning, and it also aids us in terms of response if there's any particular incident. To talk about the planning first, this will help us to make sure that our services are adequate and appropriate, and it allows us to either increase services or reduce services over the long-term period. So that's it in terms of planning. On the other hand, it also allows us to react in real time to respond to any sort of an incident that may happen. And it will allow us to implement sort of an ad hoc enhancement of services if that's what's required. This is the sketch just showing the arrangement at Tai Lam bus interchange. It's very similar, but slightly different. We deploy at both locations. We've deployed cameras, and they will monitor the queuing areas on specified routes. So it will tell us what's happening there. And in a subsequent slide, there's a photo that will show you. We can actually do virtual bus queue monitoring. So if you've ever had to queue for a bus, you will see the lines that are painted on the road, and you'll often find that 2, 3, or 4 buses will have the queues in the same area. And the system that we've set up can actually monitor an individual queue from within those number of queues, rather than just counting everybody there. All of the cameras are linked to a 5G router, and then this gives us either video coverage or cloud-based AI. So we can look at the CCTV if necessary, and at the same time that data is fed back through the pictures are fed back to the cloud-based AI, which does processing and then also does data output for us so that we can see the results. So in terms of the features that we have here, the first 2 there really talk about what we can do now, and the second 2 there talk about what we can do in the future. So in terms of now, because this is a remote location, with the 5G, it can actually give us real-time feedback, which gives us the most accurate information to what is happening here and now. Greater speed transition and the lower latency. So with the 5G, it also allows us to do that data processing seamlessly. And if we need to view the CCTV, I think you saw before from the robot demonstration, that the 4G versus 5G, you'll find that the 5G doesn't have the latency, so we can actually see real time without any breakup in the footage. For the analysis 24/7, presently we rely a lot on manual counting, so we deploy people who will actually count for a particular time frame. But that doesn't give us around-the-clock coverage, and it doesn't give us a sort of an omnipresence there that the 5G allows us to do. It's also difficult to arrange for remote locations, to arrange for people to go there. With this 5G solution, we don't have that. With the data gathered, we can also work out what a pattern is for a normal passenger queuing for a particular time of day, particular day of the week, things like that. We can identify with the 5G solution, we can identify if there are any anomalies. So if it's not normal for that time of the day, we can get a real-time alert. We can then click into the CCTV and have a look. And if necessary, if we detect that there is something not quite right, we can make appropriate arrangements to adjust the service or provide for an ad hoc enhancement if necessary. So in terms of benefits, it gives us a strong base for route planning. It's more efficient than the present manual practice because we do not have the round-the-clock presence with the manual counters. So it's more cost-effective. If we were to deploy a 24/7 person there 24/7 to gather the data, it would be prohibitively expensive. And also gives us greater accuracy. From the slide that you see here, you can see it talks about, on a daily basis, it talks about what our maximum and minimum is. If we look at this and we see that we still have a high minimum, it perhaps indicates to us that there wasn't sufficient space on the buses to actually take all of the passengers away. So in which case we can check the video and see if that's what's actually happening. If that is the case, then we can use that in terms of planning because we would know that the bus services are insufficient. We can also get instant alerts. So as I mentioned, if there's anything abnormal, we can be alerted to it straight away, as opposed to what normally happens at the moment, which is that customers will call us and say, you know, the bus hasn't come, there's a lot of people queuing. That takes a lot more time to respond. If necessary, we can have live monitoring. So the CCTV coverage works in tandem with the alert. So if the alert is raised, we can check in real time from the video footage what's actually happening at the time. And lastly, we hope to be able to incorporate this into, in due course, into more information for passengers, which would allow passengers who are perhaps arriving at the bus interchange, if there is a lot of queuing for the bus route that they want to take, they may be able to make alternate arrangements. From this slide, you can see that what we've done, what we've been able to do here is to compare 2 different days. We often find, for example, if it's a rainy day, then we would know that less people want to catch the bus, more people would catch the MTR. But we don't know exactly how much. So if we monitor 2 days, a normal day versus a day with a special event like bad weather, or with rail disruption, for example, or a special event that's on perhaps an entertainment event, or even if we have a disruption to our services, it just lets us know what the difference is between a normal day and then a particular day that we want to measure. So to conclude, this basically offers us 24/7 monitoring at remote locations, which is quite cost effective, and it's very comprehensive that we don't have with the manual monitoring. It gives us a good data foundation, which allows us to plan better for the future, and it gives us that planning for the whole range of services rather than just for limited time frames, which is what we have with the manual counting. It aids our response to incidents, especially useful at remote locations where people have limited alternatives in terms of transport, and it allows us to monitor with the CCTV coverage. And also, it's giving passengers sufficient information to allow them to plan for their journeys. And that's the end. So thank you very much.
Thank you so much for insightful sharing. Please remain on stage. Now, I would like to invite questions from the floor. Is there any question? Oh, there's a gentleman.
Thank you for sharing. Could you please share with us your views on the prospect of extending similar people counting solution to other bus interchanges and any other 5G applications to be launched in the near future?
Yeah.
Thank you.
Thank you for the question. In terms of extending it to other locations, we are looking at the moment, and we will be prioritizing working on those remote locations and also those busy locations. So the locations where it's likely that we would have a greater demand. And bus interchanges are becoming more and more common, and we're developing more bus interchanges now to offer that service to other passengers. So we are extending to other bus interchanges. We're just working out a prioritization at the moment. In terms of other uses, we're on a process or a project of installing 5G routers and people counting systems on more than half of our bus fleet at the moment. And this will serve 2 purposes. One is that it will allow passengers, if you've got a double-decker bus, quite often people will walk upstairs before they realize there's no seats upstairs and have to come back down. So we're installing people counting on the buses with an indicator that will let people know if there are any seats still available up on the upper deck of the bus, or if all of the seats have been taken already, which saves them going upstairs to look for a seat. And also in terms of the buses that are approaching a particular bus stop, passengers will be able to look and see how many people are on the bus. So it's separate from this project. It's something that's being done on the buses. So they'll be able to see how many people are on the bus coming. It's quite useful for those frequent services. For example, if there's one bus in 2 minutes and there's one bus in 5 minutes, and you see the one in 2 minutes has 120 people, but the one in 5 minutes has just 20 people, then you'll say, well, I'll wait for the extra 3 minutes, then I'll get a seat. So that's how we are looking at deploying 5G further. And by the end of this year, we should have that in just over half of our fleet. Yeah.
Well, it's really excited to have this news. Thank you so much.